So here we're looking at a geological map of Kentucky, which you can find on our website. And one of the first things you notice about this are all the different colors. The different colors representing different rock types. And the map gives us the tool to explore the geology around our area. It takes quite a bit of work to make a geological map. We use observations from the field, like locations and types of different rocks and soils. We analyze samples in the lab, which give us a better idea of the different rocks or soil types that we're interested in. And we also use computers to tie our field observations and lab data to actual places, and then look at different patterns and locations of rocks and soils, and if they're associated with any types of landforms on the Earth's surface. And then we can tie all this information together and draw areas of unique rock types or soil types to make a geologic map like this. Most of the maps at KGS now focus on surficial geology. Bedrock geology was mapped quite a while ago, but it's completely mapped. So we're working on the surficial geology now, which is basically the different soils that now overlie bedrock. So these soils could have been deposited by different processes like weathering and erosion of the bedrock itself, sediments being blown in by the wind, sediments being transported and deposited by rivers and streams, and even glaciers. And so now I'm going to walk through how we use topography to make a surficial geologic map. And topography is basically the shape of the Earth's surface. And a lot of the surficial deposits in Kentucky oftentimes are associated with specific locations on the Earth's surface. So recently we've been mapping in an area just south of Louisville, but around Elizabethtown and Fort Knox area, kind of this area here. And we'll take a look at that right now and kind of walk through some of the basics of making a surficial geologic map from the computer. And so let's zoom in to this area here. This is a closer view. So Elizabethtown is right here. Fort Knox is here. The Salt River flows through here. And the Rolling Fork flows through here. And we're going to focus on an area right in here, kind of on the edge of the Rolling Fork, just east of Elizabethtown. And so this is just your typical map that you're seeing right now, just showing locations of cities and roads. But we're more interested in topography, like I said earlier, which is basically the shape of the Earth's surface. And one of the things we have to show us the shape of the Earth's surface is what's called a hillshade image, which you can see here. So this is a very detailed image of the Earth's surface. It has all the trees removed, it has all buildings removed. So we're just looking at the bare surface of the Earth. And I want to look at this area right here. So we're going to look at this light gray area, kind of where my cursor is. Then we're going to look at these kind of long, linear, dark gray areas all through here. And then we're going to look at this light gray area in this Rolling Fork Valley here. And so we'll start here up in these high elevation areas. And so maybe here's a better way to view this. So this is kind of a three-dimensional image of what we were just looking at, but here you can see these higher elevations, relatively flat areas up here. These darker colored areas are the steep slopes. And down in the bottom of the slopes, you have this really wide flat area, which is the Rolling Fork Valley. And so we'll take a closer look. So we're in this three-dimensional image. And so we're really interested in this flat area right now. So what happens, a lot of the soils in these upland, high elevation, flat areas are formed by just in-place weathering and erosion of bedrock. So that rock just sits there, and over time, the wind and the rain and the elements just kind of break this down into soils. And we call that residuum. And we can go look at that in the field. They have specific characteristics, certain colors. We can analyze things in the lab. Again, they have certain characteristics that we look for. And then on our computer, we can kind of make broad interpretations of these large flat areas as areas of residuum. And then we start to color these in. So this takes a minute to load. Okay, so this is finally loaded, and you can see this light purple region is what mostly covers this large flat area up here. And so that light purple color just denotes that all of those areas have residuum there that overlie bedrock. And that's just a very typical surficial deposit that we see in Kentucky. Now let's look at what's happening on these slopes. So we'll move locations, we'll turn the geologic layer off and zoom in. This is that same creek valley. The uplands are up here, which you can see with my cursor, just this relatively flat area up here. And then you can see these steep slopes. So these creeks and streams have over time eroded that upland high elevation area, made these really steep valleys. And here in the bottom, you can see one of these creeks following my line, my cursor here. Now on these steep slopes, what's happening is gravity is the primary depositional mechanism. So these soils of residuum up top here are being pulled by gravity down the slopes. And so we get this, these very thin soils, again, with specific characteristics, and always occur on these really steep slopes. And again, this is a very typical soil type in Kentucky, which we refer to as colluvium. So if we were to draw this in on a geologic map, wait for this to load. And we see this light brown color along all the steep slopes here. And these are colluvium, colluvial soil types or deposits. And you see some other colors here too. These reds indicate landslides. So that makes sense. We're on steep slopes. Landslides can occur, and landslides are actually pretty common in Kentucky. And we've mapped several of those, which you can see here. And at the bottom of the slopes, you'll see these darker brown and pink areas. And these are just different types of colluvium that we can pick out. So we're trying to be as detailed as possible with our geologic maps. But basically, all the light brown, the dark brown, the pink, and the reds, these are all colluvial types of soils. They're all deposited by gravity for the most part. And then finally, one more example. We'll just look in this valley bottom here. So this creek coming through here. And we'll zoom into a different view of this. So this is that same valley we were just looking at, slightly different view. But what happens in these valleys, and like I mentioned earlier, our creeks and rivers are continuously eroding the bedrock and the soils that are in place. And so we get this network of valleys, network of creeks, and these creeks and rivers and the water, they move the soils along and redeposit them. So these are very water-dominated deposits. And we call these types of deposits alluvium. So these are alluvial surficial deposits or alluvial soils. And we have different colors for those to denote on a geologic map. Wait for this to load again. Okay, so these yellows, this light turquoise color, this darker yellow here, these are all alluvial types of soils. So these were all deposited and transported by water. So moving water kind of moved these soils along and redeposited them in different places along this valley bottom. And again, we have a lot of different colors here, the yellows and oranges and light turquoise, but these are all alluvial types of soils. We just broke them down into more detailed geology. But if we do this over and over and over on a large enough scale, we can eventually create larger geologic maps. So here I've zoomed out. This is that creek valley we were just looking at, right through here. These are the upland, kind of high elevation, flat areas up here, the light purple. Then the steep slopes are these brown areas. And you can see that we call colluvium. So the light brown, the dark brown, the pinks are colluvial soils. And then we have our water-dominated soils, alluvium, denoted by the yellows and oranges and turquoise colors.